Hello, I'm Rasitli Kalanji, and today I'll go over and answer the questions about the TF application for the summer 2025. So, the first question is imagine you are in a breakout room and a student asks you for help on a coding question you do not know the answer to. What specifically might you do to nurture a model and help demonstrate best practices in this moment? Firstly, I would normalize and say that it's okay that you don't have the answer to all the questions as an engineer or as a future engineer. We should emphasize that curiosity always it's on top of immediate answers. Then I would collectively with the students, I would try to approach the problem with the umpire method. And I would firstly start by reading the problem out loud and asking questions together with it, asking students about if they have any idea that they could think they have the solution to. After that, if we approach to an extent to solving the problem, we can resort on achieve on the last results resort, which using AI or Google or Stack Overflow. But even then, we will try not to get the immediate answer. Instead of, let's say, for example, we figure out in a specific problem what kind of data structure we are going to use solving the match from umpire, using the match from umpire. Then we can ask questions or figure out okay how we are going to use this data structure, how exactly this data structure works regarding to our problem solution, to the solution of our problem. Second prompt, I'll choose the third one because it's more relatable. So the question is, you notice that a student is alone in a breakout room that they are not assigned to. When you visit the room, the student reports that they are discouraged with their progress and want to work alone because they feel they can't contribute meaningfully in a group. I would approach it. I would approach the student well individually, one by one. I wouldn't approach that student while all the team is present, but more forcefully individually and sympathize with his issue, his problem, his worriness regarding the course or why is he discouraged. Then I will offer a request, but I will not make it forcefully. I will offer him if we could solve a specific problem together, even after if even after the meeting ends, if even after the breakout room ends or that lecture day ends. We can start again by using the umpire method. And I was thinking approaching the umpire in order. What do I mean by in order is he will start first by approaching the understatement, the first letter U. Then I will try to figure out the M, which is the matching step. Then he will do the planning, I will do the implementation, he will do the review, and I will do the evaluation. We can do reverse, or we can even not have a specific order in that matter. But it only depends to it's only matter of the individual. It's actually engaging with his own efforts, and he's encouraged by that. That's the whole strategy behind it. And if the approach succeeds, well, definitely the individual will get more encouraged. But also after, I will have like a small announcement to the whole group to the next lecture that it will be much respected that we encourage our peers and also respect their answers to a specific problem or a solution to a specific problem they are bringing to the table. There's also encouragement to disagree with that individual, but always to be respectful, agreeing or disagreeing. Prompt 3, the technical prompt. So imagine you are helping a student during study hall, teach them how to use the binary search algorithm to find an item in a sorted array. Your answer should provide the target number and its index. If the item is not in the array, return -1. Please use Python in your explanation. So, first we have to understand what is a binary search algorithm. So it's an algorithm that look for a specific value and returns it. We have to remember that the array should always be sorted, because how the algorithm finds the value is by always looking at the middle index, and it narrows it down. So if it, let's say, if the array is the length of 6 or 7, it will find the middle point of that. And then if the target value is smaller, it will go to the left side of the array. And after that, it will find the middle point of that left side of the array. And so on. It will narrow it down until it finds the target value. And if it doesn't, it will just return -1. So it looks for middle point, middle value, middle index. If does not find it, return -1. Remember, always the array should be sorted, and the problem is asking us to return the value and the index of that value in the array. So let's create an array first. Remember, always sorted. So let's do 0, 1, 3, 6, 8, 11, 13, 15. Then we're going to create a function called, let's call it binary search, with the values of target, or let's put array first and a target. That's going to be the value that we're looking for. Then we're going to create 2 pointers. So what are these pointers used for? Forget I mentioned here. So the pointers are going, let's say we have this one. The pointers, we're going to have 2 pointers, left and right, but I'm going to keep them for now left and right. So the first pointer is going to be on the first index of the array, and then the right is going to be right, the last index of the array. Then we're going to add these two. That's how we find the middle point, by the way, the middle index. We're going to add these two, left plus right, and we are going to divide them by 2 to get the middle value. So if it's 0 and 0, 1, 2, 3, 4, 5, 6, 7, 8, 8 divided by 2, 0, it's 4. So it's going to have index of 4. So it's going to be the middle. That's how the middle is going to find. And then it's going to narrow it down. If the target is 3, it's going to narrow it down to this, and so on until we find the value. So we are going to call initialize the pointers, which is going to be left equals to 0, and then right is going to be to the last element of the array. Which how we find that is by differentiating the length of the array plus 1 in Python. Then we're going to create a while loop. The while loop is going to be needed because we are going to go over. We're not going to go. We're using while instead of for loop because we're not iterating one by one. Instead, we are going kind of like subsequentially, parts by parts of middle points. So we're kind of like moving for the middle point, and we always need to have the left pointer smaller than the right pointer because this is a sorted array, and the right always has to be bigger than the left. Now we initialize the mid value by adding left and right divided by 2. And now we do the conditions. So if the middle value is equal to the target that we're looking for, then we're going to return the target together with a value, because with the index. Because when we are the problem is asking us to return the value on the target, the number and its index. Else if the middle value is smaller than the target, that means that we're going left. So how we're going to do that is by changing the left by adding the middle value to 1. Adding one more, iterating 1 more to the middle value. So kind of like pushing the left 1 more. And else, this is going to be, let me put in the comments that it's going to be bigger than the target. And that is going to be right. And we're going to decrease 1. This is iteratively. And if we don't find anything, we are going to return, the target, that what we are looking for. And if we don't find it, we're going to return -1. So now let's initialize them. Let's initialize what we are trying to find, and if it's correct. So the array, and which one from the array? Let's try to pick 13. Let's pick 13. So let's pick 13 and let's print it. We can put target to the target. These are syntaxes for Python. So if we start with f, the string, it's going to allow us to put some brackets in where, well, curly brackets, so we can put the initialized values that were initialized outside that the printed function. So for the index will be, let's say for example, we open the brackets and a curly brackets is where we're going to put the value in. But if it doesn't find it, it's going to return -1. And I think this should be fine. Let's run it. And yes, so target 13 at index 6. So if we count it 0, 1, 2, 3, 4, 5, 6. So let's say, what if we don't have, the target is not there? So 2, for example, target is not there. It will show -1. And we can try that. We can prove it. And that's it. Hopefully people find this useful, and have a good day.